Before we get into our lesson for today, there's a few things that I would like to go over in the Canvas course and other things. So I'm going to share my screen. All right. So here we are in the course. This should look familiar. Hopefully it is by now. So a few things. Let's go to the modules. Obviously, everything in Chapter 6 is there. Hopefully, you're done with everything in Chapter 6, meaning you've done the Chapter 6 multiple choice and free response questions. I did send messages out to everyone who is missing those items. If you had not turned in those items, I gave you a grade on them based on them not being done, because I want you to see what your grade might be on the progress report, because first grading period ends on Friday. And I want you guys to see what happens if those aren't turned in. So please, if you haven't done them, please do them. Also, keep in mind, like on the multiple choice, right? If you've already completed it, right, when you click on this assignment, it's going to show that it's been done and that you got a score, right? This is the test student. If I look back at the attempt, it's going to show my answers, it's going to show what I got correct, and it gives feedback to those responses on the multiple choice. So if you got it incorrect, it's going to tell you something that should help you get it correct the next time, right? So if you've done it already and you don't like your grade on the multiple choice, please look back at your attempt, look at the feedback, try it again. If you haven't done it, try it, then look at the feedback and maybe try it again. All right, so please make sure you're using these tools, right? You have unlimited attempts. There's no risk in doing it multiple times. You'll get the highest score that you get, no matter what order that score happened. Okay, so please remember that. And then on the free response questions, right? This shows obviously like my test student has submitted this, right? You could start a new attempt if you want to reassess on this. If you're doing a new attempt based on feedback you got from me, you only need to submit the corrections to things that were wrong or that you want to show a better understanding of. You don't need to redo the entire thing. Right? It shows the submission here, right? If I did like scribble comments on this, you should be able to see those. Some of you got that, some of you didn't, depending on what I was using on grading at the time. You can see comments, if there's any comments left for you here, where I put you on the rubric, right? So it's important that you go back into the assignments that have already been graded, especially if you didn't get the grade you thought you should have gotten, so that you know why and you know if you need to correct things. Right? I leave lots of feedback on pretty much, definitely on the self-assessments. Everyone gets feedback. The multiple choice quizzes, obviously, those are graded automatically and I have feedback built into those. All right. So use the course to get feedback and see what you've done. All right. Is there any questions about that, how you can go back into your turned in or submitted assignments to see their feedback? You can also see comments in the grades section. You can view comments, although it's not going to provide any like scribble down comments that I maybe wrote on your papers or your submissions, but you can view comments from here as well. Okay, so please don't forget that. Now, moving forward, we just did, over the last couple of weeks, we've done chapter 7 on sampling distributions. And the multiple choice and free response questions are available. Those are ready. I will not, these will be included on the progress report if they're submitted, but they will not hurt your grade if they're not submitted before the progress report ends this week. So if you haven't done chapter 6, those things might hurt your grade. If you haven't done chapter 7 yet, that's totally fine. You at least need a week or two to marinate on those things. We are going to be starting chapter 8 this week. Our lesson today will be on section 8.1. This is confidence intervals. And I'm in process on getting all the resources put together for this. I'm currently working on the practice problems. So we're starting chapter 8. Can also, in the calendar, looking through the end of February here, I have a tentative pasting for the last 2 weeks of February. That's including this week and next week. We're going to do section 8.1 this week. I'm hoping to be able to do 8.2 and 8.3 because they're very similar together next week, kind of like what I did with 7.2 and 7.3. That's up for possible change depending on how things go and how dense the content is. So this is tentative. And then, yeah, we get a short month next month because of spring break. So I'm hoping to get through chapter 9, right, in the first 2 weeks of March. And then the week and a half before spring break, I want to reserve that time for review of what we've covered so far. Right, and this also allows us some wiggle room on the pacing for chapters 8 and 9. Okay, so that's kind of the tentative idea for the next month. Okay, so if you want to look at that, it is in the calendar on here and on the front page. Last thing I want to go over before we get into the lesson today is there is some things available through NIMSY. Most of you should have gotten an email from NIMSY asking you to like register on Blackboard, which is a similar kind of service as Canvas is. Blackboard is a little more common in the college level. And I'll post these directions and things into Canvas as well, so you guys can refer to these if you want. This is just another resource to get help with. It's NIMSY's National Math and Science Initiative. We get some extra funding through NIMSY to help support you guys with AP courses. Some of you might be familiar with NIMSY if you've taken AP courses in the past. So you should have Blackboard login credentials. This is kind of the course registration. You have to register for their course. It for you guys here at OG, it should be free. And yeah, so there are 2 course options. There's on demand, there's live sessions. Some of the live sessions have already occurred. We got our information a little bit late here. I do apologize. There is a schedule of the live study sessions, right, and the different topics being covered. I can get a list out. I have a list of those topics that I will also include in the information that is available to you guys. So this is another resource for you guys to find materials and study help and extra support with AP Stats, if that's something that you want. All right. So that was a lot of stuff. I apologize. We had a long 4-day weekend, and so I know that was a lot. Is there any questions, comments, or concerns? About anything grades, assignments, MZ, pacing, anything at all. All right. Well, then we're going to get started with the lesson for today, and we're going to start chapter 8. All right, estimating with confidence. If you have something you've been taking notes in, which I hope you do, now is the time to get that ready. We're going to have some notes. Right. So here we are, chapter 8, estimating with confidence. All right, section 8.1 is confidence intervals, just the basics. The next two sections talk about proportions and means, similar to what we did in chapter 7, where we kind of had the introduction and how to deal with proportions and how to deal with means. This follows a similar pattern, and so will chapter 9. All right, so confidence intervals, the basics. All right, the learning objectives for today. All right, we want to be able to determine the point estimate and margin of error from a confidence interval. We want to be able to interpret a confidence interval in context, interpret a confidence level in context, describe how the sample size and confidence level affect the length of a confidence interval, and explain how particular issues like non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. So hopefully this is what we will learn today. So first we're going to kind of think about an activity. We're not going to actually do this today, but so suppose, you know, your teacher, me, Mr. Mosley, selected a mystery mean. I just randomly selected a value mu and stored it as m in the calculator, in my graphing calculator. The activity would be for you guys to work together in groups of 3 or 4 students to estimate this value. The following command was executed on the calculator. Mean, parentheses, rand normal, M2016. Right. The result was 240.79. This tells the calculator to choose an SRS of 16 observations from a normal population with mean M and standard deviation 20. The resulting sample mean of those 16 values was 240.79. Right. So we have a single sample mean, so X bar, one of those values. And we know that the parent population was normal with a mean of something we don't know and a standard deviation of 20. Right. The goal would be to determine an interval of reasonable values for the population mean mu. Right. We'll use the result above and what you learned about sampling distributions in the previous chapter. All right. So we're not going to spend time on this today. We'll see how this works. I do have a sample way of how we can do this. Would have helped if I opened that earlier. There it is. All right. So this just shows some scratch work of a possible way that you could determine the reasonable interval. Right? We have a value m, which is the mean or mu of the population, which we don't know. We ran this through our calculator. Right? This means that we have a sample size 16. Right? Mu we don't know. That's m. Standard deviation of 20. Right? And we have an x bar. The result of this function was 240.79. We're going to assume this is an unbiased estimator of mu, because that's the best thing we have to go off of right now. We can calculate the standard deviation because we know the standard deviation of the population and we know the sample size. So the standard deviation of x bar, or the sampling distribution of sample means, would be 5. And that's 20 divided by square root of 16, 20 divided by 4, and that equals 5. 5 times 3 is 15. Why did I choose 3? Because we typically, when we're looking at a normal distribution, go up to like 3 standard deviations to the right and to the left. That gives us almost all of the data, right? And we're trying to think of what's reasonable. What are the possible values of the mean? And we know that the sampling distribution is a much more narrower distribution than the actual population distribution, and it should be centered at the population mean. So this gives us a rough idea, based on the information we do have, of where the mean could be. It should be somewhere within that range, right? So then we do our mean, x bar plus 15. We get 255.79 as an upper bound. 240.79 minus 15, we get 225.79 as a lower bound. And so we say the interval of reasonable values for population mean mu is 225.79 to 255.79. And this is interval notation. It looks like a coordinate, but it means that we have a lower bound of 225.79 and an upper bound of 255.79. Every value in between there is a possible mean. Yeah. And so we know that within 3 standard deviations, we get 99.7% of our data. That goes back to our 68, 95, 99.7 rule. So we can pretty much guarantee with a large degree of confidence that the mean is somewhere between these two values. Where it is exactly, we're not entirely sure, but we know it should be between these values. Okay. Is there anything I can clarify about this scenario and how I kind of like scratch worked my way through it? Okay. And again, and this is based on stuff that we did in chapter 7, all right? Just using the sampling distribution of a sample mean. So now, confidence intervals. If you had to give one number to estimate an unknown population parameter, what would it be? If you were estimating a population mean, mu, you would probably use x bar, right? Because we assume these are unbiased estimators. If we're estimating a population proportion, you might use p hat. Right? In both cases, you would be providing a point estimate of the parameter of interest. Right. A point estimator is a statistic that provides an estimate of a population parameter. The value of that statistic from a sample is called a point estimate. Right. And this is just, again, it's linked to the fact that we consider these unbiased estimators. Right. And we can use x bar, which is the sample mean of a sample, right? Or p hat, sample proportion from a single sample. Right? We learned in chapter 7 that an ideal point estimator, or unbiased estimator, will have no bias and low variability. Since variability is almost always present when calculating statistics from different samples, we must extend our thinking about estimating parameters to include an acknowledgement that repeated sampling could yield different results. Right, so this is why we get an interval of values that are possible and not just a single estimator. The estimator gives us something to work with. Does anyone need a moment to write anything down? So now let's think of the idea of a confidence interval. Right? In our mystery mean activity, is the value of the population mean mu exactly 240.79? Probably not. Right? However, since the sample mean is 240.79, we could guess that mu is somewhere around this value of 240.79. How close to 240.79 is mu likely to be? Right, well, to answer this, we ask another. How would the sample mean x bar vary if we took many SRSs of size 16 from the population? So this kind of goes back into chapter 7. What's the variability of x bar? Right, well, if we start with our population, right, we have a unknown mu, and we know the standard deviation is 20. Right, so this is kind of describing the spread of our population. We take a bunch of SRSs of size 16 and we get different x bars. Relatively close, not terribly spread out, right? Obviously, if we had a larger SRS, we'd have less and less variance. And then we get a sampling distribution based on the sample means that has an unknown mu still, right? It should be the same mu as here. But the standard deviation is only 5, so it's a little more narrow. Well, considerable amount more narrow. Right? So, and this is exactly what we saw in chapter 7. Right? We start with a approximately normal population. We take a bunch of SRSs, we get sample means, we find the sampling distribution of the sample means, and that is also normal, but it is going to be less varied because we're focusing on a single possible value. Does anyone need a moment to write anything down from this slide? To estimate the mystery mean mu, we can use x bar equals 240.79 as a point estimate. We don't expect mu to be exactly equal to x bar, so we need to say how accurate we think our estimate is. In repeated samples, the values of x bar follow a normal distribution with mean and standard deviation 5. Again, mean doesn't have a value yet. We don't know what it is. The 68, 95, 99, 7 rule tells us that in 95% of all samples of size 16, x bar will be within 10 2 standard deviations of mu. So this goes back to our that empirical rule, 68, 95, 99, 7 rule. If x bar is within 10 points of mu, then mu is within 10 points of x bar. Because hopefully if x bar is an unbiased estimator, x bar and mu should be the same. Therefore, the interval from x bar minus 10 to x bar plus 10 will capture, right, mu in about 95% of all samples of size 16. That means that in a random sample of 16, it should cover mu somewhere. Might be, depends on where that sample lies, but the mean of the population should be somewhere in that sampling. If we estimate that mu lies somewhere in the interval 230.79 to 250.79, we'd be calculating an interval using a method that captures the true mu in about 95% of all possible samples of this size. Right. So again, we're using standard deviation and the 68, 95, 99, 7 rule to say, hey, well, based on what we know about normal distributions, I know that 95% of all my values have to lie between 2 standard deviations of the mean. So that means if I have a good point estimator, that 95% of my samples should contain the mean, the actual mean somewhere. Can you please raise your hand if you need a moment to write anything down? Right, so we have the idea of a confidence interval, our point estimate, or estimator, unbiased estimator, plus or minus a margin of error, standard deviations. Right, a C% confidence interval gives an interval of plausible values for a parameter. The interval is calculated from the data and has the form point estimate plus or minus the margin of error. The difference between the point estimate and the true parameter value will be less than the margin of error in C% of all samples. The confidence level C gives the overall success rate of the method for calculating the confidence interval. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter value. Could be the mean or could be proportion. So this is the idea of the confidence interval. It's like a percentage of confidence that somewhere in our sampling we've captured the actual true parameter value. Can you raise your hand if you need a moment to write this down? Okay. So interpreting confidence levels and intervals. The confidence level is the overall capture rate if the method is used many times. The sample mean will vary from sample to sample, but when we use the method estimate plus or minus margin of error to get an interval based on each sample, C% of these intervals capture the unknown population mean mu. So again, we see this parent population with a unknown mu, standard deviation 20, many SRSs, many confidence intervals. 95% of these intervals capture the unknown mean of the population. And we can see this like kind of visually with this kind of a picture here. So we have our sampling distribution, the unknown mu, right, and we'll just kind of like drop this down. We have all the possible values of x, right, up to 1, 2, 3, right, bunch of standard deviations here, right? And so we have a sampling. Right? Each line represents a sample, an SRS of 16, and the dot is the mean for that sample. Right? We can see that one interval misses the true mean, right? But the others at some part of the interval hits the mean, whether they're a little bit like overestimating or underestimating, the overall interval still hits it. Right? But we do get one that doesn't. This is why we're only 95% confident and not 100%. So this is what it means by they will capture the unknown mean or the unknown parameter. Maybe we're doing a proportion, that's possible too. Is there anything I can clarify about this idea? Does anyone need a moment to write anything down? Please raise your hand. So interpreting confidence levels and intervals. Right? Interpreting confidence intervals. To interpret a C% confidence interval for an unknown parameter, you want to say, quote, we are C% confident, so it could be 95% confident, that the interval from some number to some number captures the actual value of the population parameter in context. So from our example, we would say we are 95% confident that the interval from 230 to 250 captures the actual value of the population mean. Interpreting confidence levels. To say that we are 95% confident is shorthand for if we take many samples of the same size from this population, about 95% of them will result in an interval that captures the actual parameter value. Okay. I highly recommend writing these down. They contain verbiage that is correct and proper to use when interpreting confidence levels and intervals. Right. So it's good to have a note of both of these. Right. So can you please raise your hand if you're writing these down? So the confidence level tells us how likely it is that the method we are using will produce an interval that captures the population parameter if we use it many times. The confidence level does not tell us the chance that a particular confidence interval captures the population parameter. Instead, the confidence interval gives us a set of plausible values for the parameter. Right, remember, plausible is not the same as possible. Right? Possible is a much wider range. Plausible is considered more like what are the reasonable values based on what we know. We interpret confidence levels and confidence intervals in much the same way whether we are estimating a population mean, proportion, or some other parameter. Right. So we need a moment to write anything down. Please raise your hand. So constructing confidence intervals. Why would we settle for 95% confidence when estimating a parameter? Why not go for 100%? The price we pay for greater confidence is a wider interval. when we calculated a 95% confidence interval for the mystery mean mu, we started with the estimate plus or minus the margin of error. Our estimate came from the sample statistic x bar. Since the sampling distribution of x bar is normal, about 95% of the values of x bar will lie within 2 standard deviations, 2 times standard deviation of x bar, of the mystery mean mu. That is, our interval could be written as 240.79 plus or minus 2 times 5, which equals x bar plus or minus 2 times sigma x bar. This leads to a more general formula for confidence intervals. Statistic, x bar p hat, time plus or minus the critical value times the standard deviation of statistic. The critical value could be how many standard deviations within the mean are you? In this case, we're using 2 as the critical value. We want to be within 2 standard deviations, which translates to 95% confidence, right? We're with 95% of our values are within 2 standard deviations. Our critical value could change. We could want to say, okay, we want 68% confidence. I want to make sure that 68% of my samples capture the mean, right? So that can vary based on our situation. Please raise your hand if you need a moment to write any of this down. Right, so calculating a confidence interval. Confidence interval for estimating a population parameter has the form statistic plus or minus critical value times standard deviation of statistic. For the statistic we use is the point estimator for the parameter. Properties of confidence intervals. Right, the margin of error is the critical value times the standard deviation of the statistic. This is what we're calling a margin of error. The user chooses the confidence level, and the margin of error follows from this choice. The critical value depends on the confidence level and the sampling distribution of the statistic. Obviously, because those are the 2 values we're multiplying. Greater confidence requires a larger critical value, right? Because again, the critical value directly relates to how many standard deviations I am within the mean. So a larger confidence, right, relates to a larger critical value, means I'm getting farther, I'm covering an area farther away from the mean. The standard deviation of the statistic depends on the sample size n. And larger sample size, smaller standard deviation. Please raise your hand if you need a moment to write anything down. Right, so using confidence intervals wisely. Right, here are 2 important cautions to keep in mind when constructing and interpreting confidence intervals. Number 1, our method of calculation assumes that the data from an SRS of size n from the population of interest. Right, so it's assuming that we did a nice SRS, a simple random sample, an unbiased sample, hopefully. Margin of error in a confidence interval covers only chance variation due to random sampling or random assignment. Right? It does not account for other types of bias. Right? It's just sampling bias, so to say, like something happening by chance, right? It does not account for under coverage, right? Or like just taking a bad sample, right? So it's simply kind of like a data error, like margin of error or confidence, right? So again, if your data did not come from a simple random sample, right? Random sampling, random assignment, things like that, then this kind of thing kind of starts to fall apart. So you have to be sure that that's the case, or do that to the best of your ability. So we need a moment to write anything down from this screen. So then that brings us to the end of the presentation here, right? So we learned how to determine the point estimate of a margin of error from a confidence interval. Point estimate and margin of error, right? We can interpret a confidence interval in context, interpret a confidence level in context, describe how the sample size and confidence level affect the length of a confidence interval, explain how practical issues like non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. Now, I'm going to assume that some of this maybe made sense and some of it maybe did not. That is okay. We will be tomorrow seeing examples of how this is actually done beyond just the single example we saw today. And you will have opportunities to practice with some of these types of problems and hopefully make more sense of it, kind of like as we have been doing lesson and practice. The practice problems will be ready later today, and I'll have those posted. We also do have in the Chapter 8 resources. We go in here. In the notes and resources, I don't have the study guides ready yet for Chapter 8. There's a copy of this presentation from today. There are some worked examples from the textbook, and where this is in your textbook, in the digital textbook if you like. There wasn't any AP Daily videos directly about just this introduction. All their videos focus specifically on proportions or means, population proportions or population means, and that's the next lesson, and there are lots of AP Daily videos for that. Right. Many AP Daily videos between population means and population proportions, and many examples from the textbook. These are all videos, and most of them are fairly short, like under 10 minutes. Most of them are around, at least the textbook ones, most of them around 3 minutes. AP Daily videos, they're mostly under 10 minutes, like 8 minutes or so. There are also going to be some calculator instructions in section 8.2 and 8.3. We have our textbook stuff. So I have that there. I'm working on the study guides. Those should be ready shortly, as well as the practice problems. So there are extra resources available already for these sections if you'd like to see some other things. All right. Other than that, I do recommend possibly looking at some of those videos for 8.1. We'll do practice tomorrow, and then after that, I would recommend trying the practice problems that will be available tomorrow. And please, you should also start at least thinking about or working on the Chapter 7 assessments. There's a multiple choice and the free response questions, same as Chapter 6 had, right? So please start working on those when you can.